Hello everyone, this is part of a problem-solving series that would help you prepare for math competitions such as the AMC 10 and 12, the AIME, and other contests and tournaments in the advanced middle school and high school level. In this session, we will be solving a counting problem, or a combinatorics problem, I should say, from the ARML competition. Here's a view of this problem. Derek starts at the point 0, 0. So let's go ahead and create our diagram here. So we start at the point, obviously 0, 0 here, right, this point, and we are facing the point 0, 1. So we are actually facing this point over here. So that's 0, 1. Okay, this is the origin, and so we start by facing at this direction, and then we would like to get to the point 1, 1. So 1, 1 is somewhere here. So this is kind of like the final destination point, which is 1, 1. He takes unit steps parallel to the coordinate axis, so you can only go vertical or horizontal, obviously. A move consists of either a step forward or a 90-degree right angle clockwise, so basically in this direction here. And so his path does not contain any left turns, and his path is definitely restricted to the square region defined by this one here. So that would kind of set the limit in terms of the boundary of Derek's possible paths. So we need to compute the number of ways that he can get starting from the point 0, 0 to the final point 1, 1 without returning to any previously visited point, meaning that his path cannot be intersecting. Okay, so let's start counting the possible paths. I will use blue color for that. So obviously one path would be just Derek having only one turn. So he starts north direction, he makes a single turn, so this turn namely, and then he reaches this. So number of turns, so we can make a count based on number of turns, and here number of ways we can say. So when there's only one turn involved, there's only one way you can create a path here. Well, alternatively, so if you have two turns, well, in that case things will be slightly different. So what he will do, Derek will do, he will go upwards, he will pass the point 0, 1, he can reach the point 0, 2, and then you can make a right turn, that's your first angle here, and then you stop at the coordinate 1 here, the x coordinate 1, and then you make your down turn now, and then that's one way to reach this point, that's the point 0, 2 here. Alternatively, we could have gone all the way up to 0, 3, then make 1 unit to the right, and then go all the way down, that's the second one, and then you can do 0, 4, that's your third one, all the way to 0, 15, 0, 17 I should say, and so that's 0, 17, and then we make a right turn, 1 unit, and then go all the way down. So basically we have 16 different solutions, 16 different ways to reach to that to our final point 1, 1. So we have 16 different ways. Now if 3 turns are involved, let me actually go ahead and use the red color in that case so that it's kind of looking different here. So what I will do is I will start going up. Let's say I stop here, I make my first right turn, and then I do not stop at this one here, but rather I keep going, and then I stop at the level 2. And then I know exactly what to do. From here there's just one way you can proceed. So you can just go down first, and then you can make a left turn afterwards. But you have basically your 3 angles over there. So therefore we can confidently say that once you determine this point over here, it uniquely defines all your potential choices. So how many different ways can this point be selected in this grid here? So we are focusing on this section here, and obviously there is 16 points vertical here, including our starting point here, our first initial example, and then there are 16 points to the right of this point here, including the point itself. So as a result, we would have 16 squared options basically. And now finally, if we are making 4 turns, so how will things change? Well, obviously we will start the same way, so let me color it with the green color apparently. So what we will do is, let's assume we are keeping the same track here. So we go up 2 units, then we go right 2 units. At this point we stop, and then this way, instead of going just 1 unit down, we will go all the way 2 units down. So far we have 1, 2, 3 turns here. So that's our third turn, that's our second turn here obviously, and that was our first turn. And then I will make 1 unit to the left and finally 1 unit up. So surprisingly enough, this point on the upper right corner of our track actually uniquely defines this track. You can convince yourself that there is no other way that you can create a path that is successful. So as a result, when you have 4 terms, the number of ways you can color it is again 16 squared. So therefore we are just looking for the total number of ways. So all we do is to add these numbers, and 16 squared is 256, plus 256 is 512, plus 16 is 528, plus 1 should give you 529. So that would be the total number of ways that Derek, starting at the point 0, 0, with the given restrictions, can walk to the point 1, 1. So that would solve our problem.